Good day everyone, I am Seguilla and I will report about Terzaghi bearing capacity of shallow foundation. So these are the formulas that we will be using in finding the ultimate bearing capacity. So kani siya nga mga formula kay nakadepende sa internal frictional angle na meron tayo. So, if na natay internal frictional angle, tanawan nato ang table para makita ang factors na kaning NC, NQ, and N gamma. So, kani ang table. So, let's say for example na gihatagan tag internal frictional angle na 30. So, kani ang atong mga factors na NC, NQ, and N gamma. So, para mas masabtan, let's proceed to example 1. So, the figure shown is a square footing of 1.2 meters times 1.2 meters. The unit weight of soil is 17.3 kilonewton per cubic meter and has a cohesion of 9.6 kilopascal. Angle of internal friction is 28 degrees. Assume no water table exists below the foundation. Determine the following. A. Ultimate bearing capacity assuming general shear failure in soil. B. Allowable bearing capacity using a factor of safety of 2.5. C. Gross allowable load that the footing can carry. So, solution. So, since ang atong example is a square footing, the formula we will use is this one. QU is equal to 1.3 C NC plus Q NQ plus 0.4 gamma B N gamma. Then, after that, tingin tayo sa table. Ang sinabing angle of internal friction is 28. Angle of friction is 28. So, 28. So, ang atong NC, NQ, and N gamma is this one. NC is equal to 31.61. NQ is 17.81. N gamma is equal to 13.70. So, we have the NC, NQ, and N gamma. So, next, pangitaon is Q and the gamma B. So, Q, what is Q? Q is the effective stress at the level of the bottom of the foundation. So, Q is just equal to the gamma times height. 17.3 times height na 1 meter is equal to 17.3 kilopascal. So, gamma B is equal to 17.3 times the width of the foundation na 1.2 is equal to 20.76. So, nanatay gamma B. So, substitute na nato sa formula to get the ultimate bearing capacity. So, QU is equal to 1.3 times 9.6 na cohesion and times 31.61 NC plus Q na 17.3 times 17.81 na NQ and plus 0.4 times 20.76 na gamma B times 13.70 na N gamma. So, our ultimate bearing capacity is equal to 816.371 kilopascal. Next, letter B. Allowable bearing capacity using a factor of safety of 2.5. So, the formula for the Q allow is equal to the ultimate bearing capacity divided by the factor of safety. So, we have the ultimate bearing capacity na 816.371. We will just divide it by the factor of safety of 2.5. So, we have the Q allow is equal to 326.548 kilopascal. Next is letter C. Gross allowable load that the footing can carry. So, natay Q allow sa letter B. So, the formula of stress is equal to force over area. So, kung ang stress is allow, the force also is allow. So, stress allow is equal to force allow over area. So, multiply lang nato sa area ang Q allow. Therefore, we have Q allow na 326.548 times the area na 1.2 times 1.2. We have gross allowable load of 470.230 kilonewton. So, for example 2, a square footing carries an allowable load of 59,130 kilogram, including its own weight. The bottom of the footing is 1 meter below the ground surface, and the water table coincides with the bottom of footing. Assume general shear failure. Determine the following. So, given na ang NC, NQ, and NY na 35, 22, and 19. So, determine the following. A. Effective surcharge at the bottom of the footing. B. Size of footing using factor of safety of 3. C. Allowable bearing capacity. So, solution for letter A. Ang ginimpangita is just Q. Q is just equal to gamma H. So, our gamma is 1,846 kilogram per cubic meter times height na 1 meter. So, our Q is equal to 1,846 kilogram per square meter. So, for letter B, size of footing using a factor of safety of 3. So, ang example nato is square footing gihapon. So, we will use the formula QU is equal to 1.3 C NC plus Q and Q plus 0.4 gamma B and gamma. So, ang ano di ay ang gamma B is effective stress B distance below the footing. Gamma B. Not included the effective stress at the top to point of point of Q. Point of Q. So therefore, gamma B is equal to 1,965 minus 1,000 times B is equal to 965B. So 1,000 is the density ng water kay ano man saturated. So our gamma B is equal to 965D. So ipang substitute na nato ang formula to get the ultimate bearing capacity. QU is equal to 1.3 times C na 1,605 times 35 NC plus 1,846 na Q times 22 na NQ plus 0.4 times gamma B na 965B times 19 na N gamma. So, we have ultimate bearing capacity of 113,639.5 plus 17,334 B. So, next is the formula sa Q allow, which is the ultimate bearing capacity divided by factor of safety na 3. So, we have the ultimate bearing capacity divided by factor of safety of 3. Therefore, we have Q allow in terms of B. So Q allow is equal to 37,879.833 plus 2,444.667 B. So our Q allow is force over area ulit. So our formula is force over area ulit. So i-substitute lang na to, ay equate lang na to kay na naman tayo Q allow. So therefore Q allow is equal to P allow or gross allowable load na 59,130 over B square. So, and then shift solve to solve for B. So, our B is equal to 1.211 meters. So, nanatay size of footing na 1.211 meters. Next is letter C. Allowable bearing capacity. So, we have the size of footing. So, substitute na lang sa formula na Q allow is equal to P allow over area. So, we have allowable load na 59,130 divided by the area na divided by the area na 1.211 times 1.211 is equal to 59,130 divided by 1.211 times 1. Is equal to 40,319.914 kilogram per square meter. So, that's all.
Good day everyone, my name is Salvana and I will be giving a couple more examples about Terzaghi'S ultimate bearing capacity. So, the next example is a strip footing on a cohesionless soil. So since it is cohesionless, therefore its cohesion is equal to 0 or it is neglectable. Then the angle of internal friction would be 30 degrees. The unit weight of the soil is 100 pounds per cubic feet. Then the base or the width of the footing is 6 feet and the depth of the footing would be 2 feet and the factor of safety that we will use is equal to 3. So find A, the allowable soil bearing capacity, which is denoted by the Q sub allow, and then B, the net allowable bearing capacity. So before we will start to have our solution, we need to first identify the values of the capacity factors based from the given angle of internal friction. So since our angle of internal friction is 30 degrees, therefore the capacity factors are here. The N sub C would be 37.16, the N sub Q is 22.46, and the N sub gamma is equal to 19.13. So, since this specific example is a strip foundation, therefore we need to use or the strip footing formula, which is given as the Q sub U equal to C, which is the cohesion, times N sub C plus Q times N sub Q plus 0.5 times the gamma, or the unit weight, times the base of the footing times N sub gamma. So here, the value of Q, we can get this value Q by multiplying the value of the unit weight, which is 100, times the value of the depth of the footing or the foundation, which is 2. Therefore, after substituting all these given values, we can get 10,231 pounds per squared feet. So, to answer the first problem, which is the allowable soil bearing capacity, we need to use this given formula. Substituting the value of the ultimate bearing capacity that we got, which is the 10,231, all over the factor of safety, which is 3, we can get the 3,410.333 pounds per squared feet. Then the next problem is the net allowable bearing capacity, and using the given formula, which is the Q sub U minus Q, which, as what I have said earlier, we can get by multiplying the unit weight of the soil and the depth of the footing, all over factor of safety, which is 3. So we have 3,343.667 pounds per squared feet. So for the next example, it is a circular footing on a sandy clay with the given expected footing dimensions: 10-meter diameter circular footing for a circular tank, and the footing at 2 meters below ground level. And the cohesion is 30 kilonewton per square meter. The unit weight of the soil is 18 kilonewton per cubic meter. And the angle of internal friction is 25 degrees, while the factor of safety is equal to 2.5. So, same sa ginawa natin kanina. First, we need to identify the to know what are the problems. So A, allowable bearing capacity, and B, net allowable bearing capacity. So we need to first also first identify the value of the capacity factors. And in this case, since we have a given value of 25 degrees as our angle of internal friction, so 25, we have N sub C 25.13, N sub Q 12.72, and N sub gamma is 8.34. So since this problem is a circular footing, therefore we need to use the formula of circular footing in Terzaghi'S bearing capacity. So it is Q sub U equals 1.3 times the cohesion times the value of N sub C plus Q, which we can get by the product of unit weight of the soil times the depth of the footing times n sub q plus 0.3 times unit weight of the soil times the base of the footing and the times the n sub gamma. So by substituting the values, you can get 1888.35 kilonewton per square meters. So to answer the first problem, which is the allowable bearing capacity, we have to use these same formulas, the previous examples, and by substituting our q sub u divided by the value of factor of safety na 2.5, you can get 755.34 kilonewton per square meters. The next problem is the net allowable bearing capacity, and substituting you can get 740.94 kilonewton per square meters. So that is all. Thank you.